Page 323, question number 10. In this question, we have a pendulum with a string 3.60 meters long. Now we're pulling the pendulum from the bottom position up to the side until the horizontal distance is 1.80 meters. Now with that said, the length of the string from the top to where the ball is still 3.60 meters. We are looking for the change in height from the original height to the new height. Now if we just redraw this dotted triangle here, that gives us this down here. So our diagonal again is 3.60, our horizontal is 1.8. We're looking for B, then we can take our 360 minus B to get our change in height over here that we're looking for. So when we look at this lower triangle, we recognize that it's a right angle triangle with a 90-degree corner in the bottom right hand side. So that means our 3.6 meters is our C side, the hypotenuse, and our 1.8 meters will be our A side. So using the Pythagorean theorem, where A squared plus B squared equals C squared, we can rearrange that to get B equals C squared minus A squared, and then we take the square root of that whole thing. So in this case, we're going to have the square root of 3.6 squared minus 1.8 squared, square root the whole thing, and we put that onto our calculator. And when we put that onto our calculator, we're going to have the square root of 3.6 squared minus 1.8 squared, and that gives me 3.11 meters. 7, 6, 9, etc. So if we want to find out our height is going to be 3.60 meters minus our answer 3.1176 etc. meters. So that's this 3 meters minus this height here, which we just found to be 3.11. That will give us the change in height over here. So obviously this is not drawn to scale. So 3.6 minus our answer from line before gives us a height of 0.482 meters. So at the highest point in the swing, when the velocity is equal to 0, the height is 0.482 meters. Now, part B in this asks us what is the speed when it passes through its rest position. So, using our mechanical energy at the start equals our mechanical energy at the end. All of the energy, when it's being pulled up to the side like this, is going to be gravitational potential energy. So we can replace our mechanical energy with gravitational potential energy. When it swings from this point down to its lowest point, all of that mechanical energy will convert from gravitational potential energy into kinetic energy at the bottom. So we're going to have mgh equals mv squared divided by 2. The mass of the object cancels out, so we are looking for the velocity. We multiply by 2 to move that to the other side, and then we have to square root. So we get the square root of 2 times g times h. So that's going to be 2 times 9.81 meters per second squared times our height, 0.482 meters. And we need the square root of that whole thing. Now looking at our units, we're going to have meters times meters gives us meters squared divided by seconds squared. And we take the square root, that'll give us meters per second. So turning on our calculator, we get the square root of 2 times 9.81 times 0.428 meters, giving me a velocity of 3.07519, etc. So with significant digits and rounding, that's going to give us 3.08 meters per second. Now, part C in this question asks us what is the speed when it's 0.25 meters above the rest position. So we know the maximum height is 0.482 and the maximum speed is 3.08. So because we're located somewhere in between the maximum height when the velocity is 0 and the minimum height when the velocity is the maximum 3.08, we're expecting something in between 0 and 3.08. So let's calculate this. So for part C, our mechanical energy is either the kinetic energy at the bottom or the gravitational potential energy at the top. I'm going to use the gravitational potential energy at the top. When it's part way down, it's going to have gravitational potential energy and it's going to have kinetic energy. So I'm going to make that a prime, so we know those are the values afterwards. So I'm going to have to subtract my gravitational potential energy to the other side to get my kinetic energy. So it's going to be Eg initial minus Eg afterwards equals my kinetic energy afterwards. I want to convert into velocity, so I'm going to switch sides here. mv squared divided by 2 is going to equal mgh initial minus mgh final. So to calculate my velocity, first of all, I'm going to cancel out the masses. So my velocity, I'm going to have to multiply everything by 2 to get that to the other side. I'm going to have g, and if I factor g out of both terms, I'm going to have h minus h prime brackets, and square root the whole thing. So when we do that, we get 2 times 9.81 meters per second squared brackets. My first height, 0.482, minus the height that we give us in the question, 0.250 meters, close brackets. Slide that up a little bit and fire up our calculator. So, oops, forgot my square root. Very, very bad. Do not forget your square roots. Second square root, 2 times 9.81 times bracket 0.482 minus 0.25, close brackets, enter, and that gives me a value of 2.13 repeating, so that's going to be 2.13 meters per second. And that's going to make sense. It's less than the maximum speed of 3.08, and it's above my minimum speed of 0.